So my name's Rob Wooley, and I'm from the office of the CTO at Wind River. And today I'd like to talk to you about using cloud-native platforms to develop and manage intelligent systems. Next slide, Ron. So I'll start off by explaining what intelligent systems are. So for the past 4 decades or so, we've had embedded systems that are designed to accomplish a certain task. And we've seen an evolution of these embedded devices as they're deployed. Some of them may have been deployed for 1 to 4 decades, but over time, as we start to have new advancements in software and hardware, there's been an emerging trend to add extra capabilities to these embedded devices. So we saw that about 10 years ago with the emergence of the Internet of Things, where people wanted to get more information about the environments where these devices were operating. And so suddenly these embedded devices could talk on the network and they could do things that they couldn't do before. But those embedded devices continue to evolve. And as they become more capable of doing compute, and as new scenarios require more compute being done directly at the edge, these devices are suddenly able to start running machine learning models and even automate some of the decisions that need to be done at this edge. And we're seeing this happening across multiple industries, everything from aerospace and defense to automotive and industrial, even including telecommunications and medical. Next slide, please, Ron. And on the next slide, we start to see how these intelligent devices are talking to the cloud component. So on the next slide, there should no longer be a cloud, Ron. I'm not sure if it's on that yet.
Is this it?
The title of the slide is The Intelligent Systems World.
This was the one I had on our system. I'm not sure I have the latest and greatest one.
This should be the right slide deck. Could you go to the next slide, please?
I may have gone too fast, or
I think it might have gotten locked up. I'll just read the titles out and I'll just continue to do the presentation.
Which slide do you want to be on here, Rob?
It's the 3rd slide, the Intelligent Systems World.
Yeah, this one here. Okay.
Okay. So as these devices work with the cloud, they communicate with the cloud in order to better understand what operations they're performing. And this allows you to sort of knit together all of these embedded devices to act as an intelligent system. And this also allows you to provide updates to these devices to stay on top of security fixes, to retrain your models and to improve how they operate, as well as to manage and orchestrate software across all of these devices that are collaborating together to perform a task. And on the 4th slide, Intelligent Edge Use Cases, we can start to see some of the new emerging use cases that are being explored because of these new capabilities. So one very popular one that people have talked about is the AR and VR use case. And the thing that makes this important is that humans are able to perceive any sort of lag or latency between what they're seeing and their environment around them. So this is very important to make sure that there's low latency in any of the tasks that are being performed. And this really requires a lot of the compute being done at the edge. And there are other use cases such as industry robots, medical, telehaptics, and automotive that also require very quick feedback between what's happening in their environment, what's going on, and how the robot reacts, often for various human safety critical reasons, so that we make sure that no one's endangered. So all of these use cases are very important for this emerging intelligent edge. Now, if we zoom in on one particular use case on the next slide, we can talk about how this applies to a lot of our traditional customers. And for today, I'm going to focus on aerospace and defense and talk about how people are using these concepts to apply them to fighter jets and commercial aerospace applications. So you can imagine within this sector, the costs of building a jet fighter has been increasing exponentially over many decades. And this is a big problem because it's becoming more and more difficult to produce the next generation of jet fighters and commercial aircraft, and more costly, and it's even taking longer and longer, which is a big problem if you're still following a waterfall model where you have to foresee the requirements for something that might be produced over a 5-year span. So there's a big demand to actually adopt new technologies and new methodologies in order to address this problem. And the Department of Defense, and specifically the US Air Force, have fully embraced this idea, and they have an initiative called Platform One, being led by Nicholas Shylon, in order to really modernize what a jet fighter is and what capabilities it has, as well as how it's built. So on the 6th slide, we can see the software factory concept that they're popularizing for DEVSECOPS. And they've really embraced this idea of being able to create a secure DevOps pipeline to produce the software that runs on a fighter jet. And this should look very familiar to anyone that's doing CI/CD, but what's novel about this approach is they're taking a security-first approach due to the sensitive nature of the software that they're building. And they also want to incorporate all of the vendors that feed into the ecosystem that sells into the Department of Defense. And so they're really trying to build a ecosystem of vendors and software that can be used on this platform. Now, if you go to the next slide, we can sort of see the reference design for how they intend to containerize this software factory. So they've taken the CI/CD pipeline that was shown on the previous slide, and now it's being shown vertically, and the tools are on the left-hand side. So their intent is to make it possible to go to their Iron Bank repository of all the containers provided from open source and from commercial vendors, and be able to integrate those into this DevSecOps pipeline that they've specified. And this allows the flexibility for all of the people building software for the Department of Defense to be able to work on a common platform, but at the same time, use the containers to change those components that need to be swapped in or out based on the project. And many of these services include things like doing static code analysis, or running various security scans or license scans and verifying the provenance of the software to ensure that you know what software you're using, what security bugs might affect it, and also make sure that you're getting it from sources that you can trust. This also allows them to reproduce the software being used in these aircraft so that they can continuously upgrade the capabilities. They can ensure that their regression tests get run so they have the peace of mind that this software that's going into flight is what they expect and performs properly. But moreover, because they have this platform, they're able to actually tag any reports generated from their testing phase and tie it straight back to not only the source code that was used to produce it, but also how it's built. So they've got a full chain of custody of how the software is being developed for this mission critical system. So if we flip forward to slide 8, that's where Wind River comes in with Wind River Studio. So Wind River Studio is the first cloud-native platform for doing this type of development for these mission-critical systems. And it not only includes the development and the deployment phases, but it also takes in consideration how you want to do your operations and servicing of these intelligent edge systems that really do require high security, safety, and reliability. Now, you may be wondering, why is Wind River in a position to speak to this topic? So if we flip to the next slide, Wind River has actually been in this space for 40 years. We're most known for VXWORKS, which is the leading real-time operating system for industrial, medical, aerospace and defense, and telecommunications applications. And we've proven this through the work that we've done with our customers. We're literally in billions of devices on Earth, including all of the Mars rovers up on Mars. And the VXWORKS continues to evolve as an RTOS with new capabilities, things like adding support for machine learning and higher level languages like Python and Rust. And so VXWORKS is really evolving with this shift towards the intelligent edge. And if we flip to the next slide, you can see just some of the mission critical certifications that VXWORKS can be used for. Everything from industrial and automotive to aerospace and medical. And VXWORKS is a cornerstone for all of these applications.
Hey, Rob.
Yep.
You know, when most people talk about the edge, they're talking about remote offices, you know, a satellite location in a relatively unpopulated world. I think you get the award for the ultimate edge, meaning Mars. I don't even know how many millions of light years away it is, but that's clearly the edge.
Yep, NASA has certainly done a good job of stretching the limits. And on the next slide, we sort of shift from the talking about development to talking about the operation of these intelligent edge devices. So going back to Nicholas Chalan, they're not only interested in using containers to change how they develop the software for jet fighters, but they're also interested in being able to use this technology to change the software. So the software that the jet fighter takes off with is not the same software that it lands with. And they've done some great work here. They did some prototyping back in 2019 where they actually had Kubernetes and Istio running on an F-16 cockpit. And then more recently, they did a test flight last year where they had Kubernetes was actually orchestrating the software that controlled a computer that monitored various assets on the ground and provided mission information to the pilot and was able to actually help operate the mission and instruct the pilot on what the mission parameters were. And this was on a Lockheed U-2 Dragon Lady. And we've also had discussions with various airport infrastructure companies that are interested in being able to use this in the commercial space and actually update software on commercial planes when they're docked at the airport. So then the question becomes, technically, how can we make this possible? So on the next slide, we can see what we've done is we've actually extended VXWORKS to support containers. And this is containers in true sense, the OCI containers. We adhere to the image specification and the distribution specification. And this is really important because people want that IT-OT convergence and they want to be able to use the same development tools and management tools that they're familiar with in the enterprise on these embedded systems. However, because of some of the other constraints for things like real-time and safety, we needed to innovate and come up with ways to support these specifications, but do it in a way that was relevant for an RTOS and for embedded devices. So, for example, we have managed to implement the core container runtime on VXWORKS to fit within 100K, so that it can fit on some of these embedded devices that might be resource constrained. And that also puts it in the range of being able to certify it. And we've been talking with customers about being able to certify this so it can be used in these mission critical systems that do have very strict certification rules. And VXWORKS is able to actually pull these containers from Docker Hub, from various container registries, and run those VXWORKS applications on the device, having pulled them down from the cloud. Now, once VXWORKS is capable of doing containers, on the next slide, we now talk about how these intelligent systems actually converge together. So this this is the starting of the connection between the core machines running in the data center and these edge devices, as Ron mentioned, that are running on Mars, running on wind turbines, running in a factory. And it's really important to provide the infrastructure in between, because many of these systems may not be talking directly to the data centers. They need to talk to equipment in between that is also mission critical in order to facilitate that communication and make sure that it's low latency and also secure. And for many people, like in industrial or aerospace and defense, you can't rely on public infrastructure. If you have an emergency response team, they may need to create the infrastructure as they're rolling out to save people's lives during a large emergency, such as forest fires or some other emergency. And so this is where Wind River can help as well. By leaning on our experience with networking and telecommunications, we can actually offer the Wind River Studio cloud platform, which is a resilient server that can be used for the providing extra compute power as an edge data center. And this is leveraging all of our favorite cloud native technologies. So on the next slide, we can talk a little bit about the capabilities of Wind River Studio as an operator. So it's based on the Starling X open source project, which we contribute to, and it includes things like Kubernetes, Docker, Containerd, and it also supports OpenStack for people that wish to be able to manage VMs. And what this really offers outside of your standard Kubernetes is the ability to take it outside of the data center. Because when you have numerous machines that are on a reliable network with a reliable power supply, it's very well suited for your vanilla Kubernetes. But when you take it out of the data center and you now need to protect it from people that might have physical access, might also not have many other machines to hot swap to if there's a problem. You need to have extra capabilities to guarantee reliability of the system, as well as high availability to be able to swap over to any other nodes that you might be co-located with. We also have to make sure that it's scalable, because for some of our customers, they want the ability to scale up to thousands of nodes by using distributed cloud with Kubernetes control planes connected together. And ultra low latency is a key tenet because we want people to be able to use this for 5G, where you really need real-time reaction time to be able to communicate between some of the virtual radio access networks and some of the other nodes in the system. And as I mentioned, security is important, but also lifecycle management. When you're managing thousands of devices, you need an easy, clear, single pane of glass to provide a dashboard to update you on how all of your thousands of nodes are doing, but also provide a simple way to operate those nodes and keep them up to date. And this is achievable through the many extended capabilities we've added, where we're managing the hosts and the infrastructure they're running on, we're detecting faults and taking appropriate action based on those faults, managing the software, and adding extra capabilities like allowing them to be distributed geographically, do zero-touch provisioning for nodes, where you can't just send someone to go and update them, or to provision them rather, as well as operations automation of the layers running underneath Kubernetes. And if we go to the next slide, we can see that Wind River Studio is already being very popularly adopted through our customers, particularly for 5G, which is where it got its start. It's been embraced by Verizon and Vodafone and T-Systems as part of their initiative to roll out their next generation 5G cloud. And we're also in discussions with various customers in other segments like industrial and aerospace and defense about being able to leverage the operator capabilities of Wind River Studio in those spaces as well. And if we go to the next slide, This really sort of positions Wind River Studio as the platform for mission critical intelligence systems, because we cover both the development side for building the software running on those systems, as well as a capability for really managing and operating those devices that are really running out there on the edge. And if you're interested in seeing some of the capabilities of the development side, you can take a tour of these capabilities at windriver.com/studio/tour.